K-means clustering is an unsupervised machine learning algorithm used to cluster unlabeled data points into clusters. So let us see how this algorithm works. First of all, let us consider a set of data points which is shown here. These are in a two-dimensional plane, and by visually we can see that they are into three groups. But when we go into higher dimensions and when the data points are not ordered, it becomes difficult to find out the number of clusters to group and also to assign each data point to a cluster. So K-means clustering is a kind of heuristic algorithm which actually provides a method to cluster these data points into groups. So let us consider n points in the d-dimensional space indicated using the x, capital X, and x1, x2 and x1, xn are the individual data points. Our goal is to partition this data into k clusters such that the points within the cluster are similar and points in different clusters are far apart. For example, we would like to group these all set of points into k clusters such that each point is closer to the points of that particular cluster, and it is far away from the points of the different cluster. So we would like to find out this assignment of each data point belonging to a certain cluster such that this whole overall thing get minimized. And this can be mathematically formulated as follows, where mu i's are the centroids and the ci's are the clusters. And we would like to assign each of these points to one of those clusters such that this overall thing gets minimized. But this problem is a very hard problem to solve, and which is NP hard, and therefore we choose some heuristic algorithms to solve this problem. So one such algorithm is the Eloit's algorithm. So K-means clustering employs this Eloit's algorithm, which is a centroid based technique that partitions data into k distinct non-overlapping clusters based on feature similarity. And let us see how this algorithm works and obtain these k clusters. Let us discuss about the Eloit's algorithm, which is an iterative process of computing the optimal centroids. This contains two steps. One is expectation step and the other is maximization steps. So in the beginning, we have from the set of points we choose k points as centroids, which is chosen randomly, and we try to assign each of the other points to one of these centroids, one of these k centroids. This step is done by first computing the Euclidean distance between the data point and the k centroids, and whichever centroid has the least distance, we assign this data point to that particular centroid. So in this way, every data point is assigned to one of these k centroids. So in the next step, we update these centroids, because since we earlier chosen the centroids randomly, now since we got data points to each of these centroids in the previous step, assignment step, we recompute the centroids based on the data points which has been assigned to that particular centroid. Now the centroids get updated in this step, and this process of assigning data points to the centroid and computing the new centroids goes on iteratively, where we call this assignment step as expectation step and the updating the centroids as the maximization step, and thereby we iterate this process until these centroids does not change or it reach to the maximum number of iterations. So this is how the Eloit's algorithm work. First we choose random centroids and we make an assignment, and we recompute the centroids by the points which have been assigned to the particular cluster, and these steps of assignment and centroid computation keeps on iteratively go on until we reach to the convergence. So let us now see one example to better understand this. Consider these 6 points, and we would like to find out 2 clusters. So this number is actually a heuristic number. We don't know how many clusters we have in the data. That is a big problem to actually find out how many clusters are there. So there are other advanced algorithm which attempts to find out the number of clusters. So we'll see that also soon in the later videos. But k-means does not have any way to determine how many number of clusters. Here we are choosing randomly k is equal to 2. So first step is to compute the centroids. So first we choose random centroids. So here I am choosing 1, 1 and 2, 1 as the random initializations. So we can choose any other points also as the first initialized centroids. So now I compute distance between each of these points to these centroids. So for every point I compute the Euclidean distance and assign to one of these centroids. So as you can see here, these are the 2 points, 2 centroids which are indicated using these diamond symbols, and these are the data points which we have. Now I would like to assign the each of these points to this centroid. As you can see, since all these points are belonging to the blue color, which indicates that this belongs to this particular centroid, there is no data point to this centroid except 1, 1. So in the next step, what we do is, since the assignment is done, we recompute the centroids. So when you recompute the centroids, this is what we get it, 1, 1 and 4, 4. And these new centroids, we got it based upon the previous assignments. So in the previous assignments, we have 2, 1, 4, 3 and so on, all these points. So if you take the mean of these points, we get these 4, 4. And the previous centroid 1, 1, as there is only one point, so it remains same. So we have recomputed the centroids now. So we started with 1, 1 and 2, 1 as centroids as random initialization, and now we got the new centroids 1, 1 and 4, 4. Once we obtain the new centroids, we do the assignment step once again. So as you can see here, this is the new centroid 4, 4. Now when we do the assignment step once again, it would look something like this. So each of these 2 points belonging now to 1, 1 and the other points belong to the 4, 4. So in this way, the centroids gets updated and the clusters get formed, as we now have the 2 clusters based upon their similarities with the points which are belonging to that particular cluster, and also maintaining the far apart distance with points of other clusters. So in this way, these 2 steps of centroid computation and assignment goes on until we reach to the optimal clusters. So this is how it is indicated. Let us now see one demo for a set of points. So as you can see here, we started randomly, but as the centroids are getting updated and the assignments are also getting changed for different iterations. So finally we settle with some optimal centroids and the optimal set of points assigning to each centroids. So this is what is the k-means clustering demo. So important step is, how do we find the number of clusters? It is a very challenging thing. So one method which suggests is this called as elbow method, where we try to plot the error with respect to the number of clusters. So if you have only one cluster and if you compute the error, this is what is given. If you have 2 clusters, you have this. If you have 3 clusters, you have this, and so on. So elbow method states that whenever there is a sudden change in the variance error, where the elbow of this curve, we try to choose that as the cluster. So you can treat here as 2 as the elbow, because there is a sudden dip in the change in error, and this is one way to find the number of clusters. And there are other ways to also find. One is the silhouette clustering, which measures how similar an object is to its own cluster compared to other clusters, and this value usually ranges from -1 to 1, where a high value indicates that object is well matched to its own cluster and poorly matched to neighboring clusters. And if most objects have a high value, then we can say that the clustering configuration is appropriate. If it has a negative value, then we can say that it is the configuration is not proper. So this is another way. In the demonstrations, we will see how elbow method works by implementing in Python. Let us discuss how k-means algorithm works. Here we are initializing random and math library. For visualization, we are using matplotlib, And in the first, we write a method called Euclidean to compute the distance between two vectors. We have a method to compute the mean among the points. And this is the core of the k-means algorithm, where we initialize all the set of data points, k centroids, and 100 iterations. And in the beginning, we randomly initialize centroids by taking k set of random points from the data as the centroids, and we iterate for 100 iterations. And first we initialize clusters as a two-dimensional list here, and we take every point from the data and compute the distance between the k randomly initialized centroids. So we take every centroid from these, compute the Euclidean distance, and we, for that particular point, we try to find out which of the centroids have the least distance by employing this min method. And once we obtain that index, we store this index into a clusters list, which we have initialized here. So once we do this for every point which is there in this data variable, and we compute the nearest centroids. So once we obtain the assigning the each index for every data point, we recompute the centroid. So this is the assignment step as discussed earlier. And here we are recomputing the centroids by using the assigned points. So once we obtain these new points for each cluster, we compute the mean of them and append it as a new center or the new centroids. So in this way, we obtain the new centroids for all the clusters, and we later assign this same to centers variable. So once again, this process starts for a second iteration. In the second iteration, once again we recompute the distance between every point and to the new centroids, and once again compute the new indexes, and later use the same assigned points to compute this centroid. So this process of assignment step and the centroid computation steps goes on until this 100 iterations in this case. And so this is what we have initialized. We have initialized with a random set of points here to just see how it performs. So we have called this k-means function, and we have visualized by using matplotlib, and this is what we get for 3 centroids. So we have divided this whole data points into 3 centroids. These are the final centroids we got after 100 iterations. So let us see what happens if we change the number of clusters. For example, if I change this to 4 clusters and run this, let us see what sort of output we get. As you can see here, now we have 4 centroids with 4 clusters. This is obvious and intuitive that this whole segment has been divided into 2 parts, and it got its own centroids. So in this way, we can test with various number of points. For example, if I choose only 2 centroids, this is what I get it. And if I choose, suppose, say some 6 centroids, and if I compute, this is what we get it. So by changing the number of centroids, we can get the appropriate cluster centroids and the assignment of each point to its corresponding centroid. So how do we find the number of clusters? As I stated earlier, elbow method is one way to find out. So first we compute the error between the overall error of points belonging to a particular cluster, and so when you run this, and you later try to plot this error for every set of number of clusters. So as you can see here, this is what is the point where we have a there is an elbow kind of a shape. So we choose 2 in this method for as the optimal number of clusters, and the other method, which is Silhouette method, can also be employed to compute the number of optimal number of centroids. So if you compute the Silhouette score, so we get something as follows. As you can see here, k is equal to 2, we have a maximum score. As we said earlier, the values would be between -1 to +1, and and if you compute for all the points, and if you get the total score more positive, it indicates that that particular number of clusters are kind of optimal as compared to others. So in this way we can use one of these methods to find out the optimal number of clusters.